Good morning. I think I can walk around and you can still hear me. Sounds like it. I'd like to talk to you about this project, the Array of Things. And typically, I will go into great detail about why we built the Array of Things, what it is, what it does, what the computer science challenges are. But this morning, what I want to do is kind of flip that around a little bit and talk a lot more about why we did it, and then talk about who we're working with to bring some value out of the thing that we did. Like just every project that we've done, we meaning the team of people I work with at Argonne and Chicago, we have tried to respond to the needs and requirements that we hear from, primarily in our case, from folks we talk to in the city of Chicago, to see where there are opportunities to provide research or insight or new capabilities to the city that are relevant to the challenges that they have and also are relevant research issues. So turns out there's quite a bit of overlap there. That's in contrast to what I think is much more typical from my world of research, where you go in your laboratory and you work on this really cool shiny object, gadget, and then you go and you say, look at this hammer and look at all your nails, right? So it's not like we've never been guilty of that, but the Array of Things project is really one that has grown up from conversations with cities, and primarily the city of Chicago, but also with the science community that's interested in that set of challenges that give them relevant research questions and then provide city leaders and even community members with capabilities that would address some of those issues. You can see, I will say we a lot. I work with a fairly large team of people to do this project. Now, when we first started, so I spent 25 years in internet and high performance computing, supercomputer centers, and things like that. Took a sabbatical after spending a couple of years, 4 years as CIO of Argonne National Laboratory. Took a sabbatical to recover from that. And I thought, well, I could go back and do high performance computing. That's fun. But I had read some books about cities and about global urbanization. And I was really intrigued by the challenges that cities were starting to exhibit, different than the challenges that were typical of the 20th century. And so I started talking to social scientists, economists, and others, and then eventually to people in the city of Chicago as Rahm Emanuel started bringing in some really creative people at the commissioner and department chair level. And I was struck by the approach that the city was taking, which was to use data and technology not for its own sake or for some, just interest in technology, but to make things better for the people that live in the city. And that's what really inspired me to do Array of Things. So I will talk to you about my gadgets and the science that we do, but what I'm really motivated by is how do we use this stuff to make it easier for people to live and take opportunities and work and go to school and other things in cities like Chicago. And you've already read these quotes by now, and so you can see that I think when it comes to things like smart cities, which is often associated in government with IoT, I think it's really about the people. Now, I think it was probably 6 or 7 years ago, Chicago was one of the Rockefeller Resilient 100 cities. So there was this big workshop that was not much larger than this, that the mayor and the Rockefeller people and Arab Engineering had. And that was a workshop that opened my eyes as an engineer and as a computer scientist to a much broader set of opportunities for technology in cities. Because I thought about smart or resilient or sustainable all in the lower left-hand quadrant of this circle, having to do with parking and congestion and energy and other things, all important things. But I didn't really make the connection that a city that's sustainable also has to provide economic and education and other opportunities to its residents, has to plan ahead, and it also has to think about the health and well-being of its residents. So when I think about IoT and smart cities, I'm actually finding that the more interesting problems for scientists are in the upper right in the lower right of this diagram. The other ones are, as I said, interesting and important. The second thing that I started to discover for me, it was a discovery for me about cities, is that they're not these big homogeneous things. They are really collections of neighborhoods. And when you zoom in on those neighborhoods, or you zoom out and look at the different characteristics of those neighborhoods, you find very quickly that where you live and where you grew up in a city has a huge impact on your development as a person and your opportunities. And these 4 maps are just 4 different slices of that phenomenon. On the left-hand side, if you were born in 2017, if you're born in Hyde Park, your life expectancy was a dozen years longer than if you had been born a mile to the west and a little bit south in Englewood. That's even if you correct for crime rates and racially specific diseases and things like that. There's something about the urban environment at a granularity of a square mile or less that affects people's health and well-being and the rate at which they age. Second one is asthma. Although these maps, you can kind of squint your eyes and say, oh yeah, I can see the west side and the south side are the parts of the city that struggle the most. But if you look a little closer at the asthma, it's not just, it's not air quality, or asthma is not just tied to income or economic opportunity, because some of the areas that are very high income and very high opportunity are also some of the areas with very high asthma rates in that map there. The next one over is transportation. What are your opportunities for getting to jobs or work or school depends on where you live in the city. And that is, this map here shows the number of minutes from every point in the city to get to the Chicago Loop as a proxy for opportunities like jobs. So number of minutes it takes to get to just right up here. And that is a set of opportunities or not. The green is 30 minutes or less, the purple is an hour or so, and the gray could be an hour and a half, right? So your opportunity, because of where you're born, was locked in place in some sense by decisions that were made 2 generations before you were born, like where do we lay the train tracks, or where do we route the buses? And then finally, on the right-hand side, the one that's even more hard to read than the others with the light is there's been a lot of studies in Chicago and other places about food deserts, right? So if we say a grocery store that's less than 2,000 square feet is a kind of a proxy for too small to have fresh produce and other healthy food, then these are the neighborhoods, the gray neighborhoods there, where you really can't, in walking distance from where you live, you can't get to a place where you can buy healthy food. The hashed, well, you can't see it anyway, but this is also, you can see that a lot of these are predominantly African-American communities. Now, if I were to show you the map of fast food, so if you really want to raise your blood pressure and, you know, increase your BMI, there's no problem at all. You can easily get to fast food. It's all over the city. So that's a health issue that is driven by economics and infrastructure and other things. So now, before I then talk about the array of things, we started to learn about the kinds of things that the city of Chicago does with their data. And a very simple project, but a very impactful one that we entered into after it was already going. The city was working with all state data scientists and others. And what they were doing was responding to a need that was expressed by the Commissioner for Public Health, who said, I have 35 inspectors and 15,000 places to inspect. How do I do that more efficiently or more effectively? In other words, where effectively is we find and we fix food safety violations as quickly as possible. So the data scientists led by Tom Schenk, and Gene was part of this as well, in the city's Department of Innovation Technology, developed a predictive model based on about 30 different leading indicators, including things like weather and the name or the type of restaurant, the size of the restaurant or grocery store, the neighborhood that it was in, that sort of thing. And just rank ordered, or not rank ordered, but ranked each establishment as high, medium, or low risk for a food safety violation on the next inspection. And by changing from a random inspection order to a targeted order that was risk first, what you see in this graph here is they were able to start seeing and addressing food safety violations about a week in advance of what the the random ordering would give you. Now, as the Argonne folks got involved, we helped them to perfect that, but it's representative, this project, of a lot of data science projects where you want to look at lots of different factors because they have predictive value in what it is that you're trying to optimize. Whether that's a food safety inspection or it might be an elevator or fire inspection, lots of data sources. So we started thinking about the array of things. I will say, modulo my earlier comments, the idea for the array of things was very opportunistic. I happened to be in a meeting, somebody from the city said, oh, we're going to replace 300,000 streetlights with LEDs. And in the back, what I heard was, we're going to roll bucket trucks to 300,000 places. So I kind of said, do you think we could put something up on the pole while you're doing that? Not really having a sense of what that would be, just seeing that there was an opportunity there. And the idea kind of rolled along. And then what we did was we eventually ended up with this array of things project. One of the things, as you'll see, that we measure is air quality. So one of the reasons that we did the array of things project is for a lot of those things that I showed you, like those color-coded maps, the measurements that we have to get data about those neighborhoods are either not there at all, or they're kind of fuzzy regional measurements. If you look at air quality, I thought, all of us know that over time, air pollutants are going to have an impact on your health. What we, the science community, has learned in the last decade or so is it's not just your lungs, but it's also your cognitive development that can be affected by air pollutants. So now you think about that map again, maybe people are aging quickly in some places, partly because of the air pollutants that they're daily being exposed to through no fault of their own, other than that's where they happen to be born. What I have learned in the last year or two from just, kind of doing my homework is that the impact of air quality or air pollutants is maybe not instantaneous, but it's like on a day-to-day basis. And I would say, if you're going to take a note this paper in the lower right here that came out in January this year. They did this appalling experiment. I say appalling because people were involved, and I'm not sure what their experimental design was, but they ended up doing the following. They took children that were in the same zip code, so same neighborhood area, and some of them were downwind from an air pollutant source and some of them were upwind, two different schools. The one that was downwind, the school downwind, higher rates of behavioral issues and lower grades in performance than the one that was upwind. And they took some students and swapped them. And what they found was that when a student went from upwind to downwind, in general, behavioral issues increased and grades went down. That's what's appalling, is that I'm glad it wasn't my kid that they moved downwind. But it's interesting to know that even within a city, the place that you see air pollutants come out has a lifelong effect on the opportunities that those kids have in that grade school. And I mean, like, if you look at studies of things like moving to opportunity, or Raj Chetty's work at Harvard studying income and education over many generations, the impact of air quality on your local school can add up to hundreds of thousands of dollars of income for the kid as the kid grows up. So a huge impact for air quality. And yet, what do we know about air quality for Chicago? You see the asthma map on the left. On the right-hand side, vast areas of the city, we have no information about air quality. The blue boxes are the important ones. Those are the EPA sites, but they're very expensive, so there are only a few of them. For all of Chicagoland, 6,000 square kilometers, 23 EPA sites. For Chicago, just the municipality, there's a dozen. And not all of the measurements are taken by all these. One on the top of City Hall in Aurora, outside the city, is in Chicagoland still, only measures PM 2.5. The one on top of the City Hall in Naperville, a little bit closer into the city, only measures ozone. So we looked at these gaps, and then I've also shown, well, what's happening with consumer, citizen science and consumer electronics. And yes, people are putting the green circles, air quality systems in their homes, not in their neighborhoods outside, which are different. And then weather underground is, you'd think would be, ubiquitous. It seems that way if you look at the map, but in Chicago, the entire south side and most of the west side, there's no measurement from anything, whether it's a regulatory system or citizen science. So how do we fill that gap? We can't go to the EPA and say, okay, can you build another 20 of these sites at a cost of probably a couple $1 million per site. That doesn't seem like, even for Chicago, it's practical, certainly not for an entire country. We went out to the science community when we had this opportunity to put a gadget up on the pole, and we had a series of workshops over about a period of 5 years. And most of them were about half the size of this group here, a bunch of climate scientists or urban weather scientists or transportation scientists or social scientists. And we would ask them the same question. If we could put a couple hundred gadgets up on poles around a city like Chicago to answer the questions that you're trying to answer, what would the gadget do? And the aggregate of all those answers turns out to be a bunch of sensors that you can see on the left-hand side and a bunch of things you can't measure with sensors. If I want to know, for example, if I work for the Chicago Park District, we're talking with them about placing devices around park facilities because they have no way to know how many people use a park. So if you're in the Chicago Park District and somebody says, cut your budget by 10%, where do you cut it? Because you don't know the high demand parks or the parks that nobody's using, because there's just no data about that. But you can't go to Fry's Electronics and buy a park utilization sensor and plug it into a Raspberry Pi, right? You have to observe. And that's the way social scientists have done their science for as long as there's been social scientists, is observation. So we thought, with artificial intelligence, with faster processors getting cheaper and smaller, we can do a sort of Internet of Things project throughout a city like Chicago and actually put intelligent things out there with processors that could process images. And that means that we would add a sky-facing camera, a ground-facing camera, and a microphone to get sound levels. And by the way, I often, when I have longer time than this, talk a lot about our privacy policy, and I'll give it to you in a nutshell, and I'd be happy to point you to our website and talk to you later. We take these images inside our box, and we save a few minutes worth of them, and then during that period of time, we run software to analyze an image or a sequence of images. We get the answer out. Right now, we're counting the number of people that we see in a scene and number of vehicles. Then we report those two numbers, and we delete the images. So this is a device that's using edge computing, or AI at the edge, to come up with a way to do this kind of analysis without creating a surveillance system that has all sorts of challenges, both legal and technical and logistical. So now what I want to do is illustrate what we're doing with the array of things by walking you through projects and partnerships that we have associated with the project. The first, I would say, is installation. These things have to be hardwired with electricity because they have to run 24/7. They have a cellular modem. You can see a picture of the device that I think that's Jimmy. Bob is on the left, who's the head of the supervisor of department head of electrical operations for Department of Transportation. So in the top of that white dome that is on the left that he's holding there is a cellular modem. We have these things on campuses with Wi-Fi and Ethernet and other things, but we use cellular data out in cities like Chicago. But it's not just CDOT that's been installing these for us. Now we've shipped some nodes just recently to fleets and facilities management because they're interested in specific questions like the pedestrian traffic along the riverfront trail that was just a major investment by the city. Crown Castle Communication is a company that's putting in 2,000 5G antennas, and they offered to throw one of our devices up in any of their locations if we would like. We said, well, yes, we would like that. So we gave them 7 to just kind of try it out, and they're going to be putting some up. And then I mentioned the Chicago Park District already, who's given us a lot of places they would like to place these things because, there's been this huge investment, for example, in the lakefront bike paths and running paths and things like that. So what are any kind of safety issues that might be coming up there? What's the utilization of those paths? These are the kind of things that we can do with current technology with image processing. So this is what the system looks like today in Chicago. Modulo, a number of these nodes have died mysterious deaths that we're diagnosing. I should say the array of things is not a smart city technology. We are not a company. We are not trying to be a company. We are not a service provider or a facility that's up and operational and supported. We are a research project. And part of our research has been to try to figure out how do you build a device that can reliably perform out in a city and give you useful sensor data. I say useful sensor data because a lot of the sensor systems that are deployed, I've been using the analogy that, you know, when you buy a new car or just browse a new car, there's a sticker on the side that says miles per gallon. Does anybody get anywhere near those miles per gallon when they actually drive the car? No. Well, that's kind of like what the sensor data sheet tells you it is, except the difference between what the sensor should do and what it actually does is also driven by where you put it and how you package it, and it's a huge difference. So there are a lot of sensor networks out there that are really good random noise generators, but not so good at measuring what it is they're trying to measure. And so we were trying to figure out how do you do that. Now, you've also read all the way on the left-hand side by now the projects that we're trying to support with this infrastructure, and they're kind of grouped in different areas. You can see where we're going now. The next set that go up, we were gonna increase to 200 this fall. What I decided to do instead was just push to 150 and then replace a bunch of the nodes that are now like 2 years old. Simple things like the camera lens is now, after a year, we've noted that the camera lens will collect enough dust that the camera is giving us not very good images anymore. So new ones have a dust shroud around them. So this is sort of an approximation of where we'll go. And I'll just point out a couple of new projects that have joined us here. The sideways left pointed arrows there are about 20 or 30 of them up there. That's a really interesting study on aging in lower income neighborhoods that's being done by Kate Cagney, who's a social scientist and director of the Population Research Center at UChicago. And she got this NIH grant partly, she says, because she told them about the array of things and how we could give them air quality information and noise information and other things. So that's one of the main things. I've already mentioned 2FM, Fleets and Facility Management. You can see in the loop diagram up in the top left there, the 3 stars, those are along the river walk, because they want to know how does the noise ebb and flow throughout the day, and how many people are actually using it, and that sort of thing. I usually have my slides memorized, and so I'm not turning around and looking at them. But as I told you this morning, I tried to do a different presentation. All right, so I've talked about the technology, all the things that we're measuring. All the data is free and it's open. You could pull up your smartphone or your laptop right now. You could download every piece of data we've ever collected. And remember what I said about images? You're not going to find any images there, but you will find integers that say at this corner there were 30 pedestrians at 9 in the morning on August 15th, for example. We provide the data. So our project was funded by the National Science Foundation, and it was funded to produce a data stream that since we had worked with lots of science communities, we were going to rely on them to do the data analytics, and that's still sort of the model, but we felt it was also important to not just have the download site, but also work with the city of Chicago, and this is an ongoing project, to try to figure out how do you integrate this kind of information into an open data portal like Chicago's Open Grid at the upper right there. And part of that is developing APIs. So you can also, if you choose to, if you are the kind of person that develops applications, you can use our API and develop a real-time application. And maybe you can develop a application that you can then market as a commercial endeavor. It's open data, it's free data, so what you do with it is up to you. And so our hope over time, as that database gets fuller and fills up with more longitudinal history, that we'll see new applications coming out. And it turns out that comparing the download site to the API, most of the traffic we're seeing is at the API. So we do know people are developing applications. So now a couple of projects with Cook County and Department of Environmental Control, and Pinaki Banerjee is our contact there, and with the Illinois EPA, we've placed our devices, several of them, at an EPA site on the south side of the city that measures like 5 or 6 variables that we're interested in. And we've got scientists that we're working with at DePaul University in Chicago and Northwestern who are comparing, as you see on the right-hand side here, EPA data versus our data. In this case, that's for ozone, which it turns out is a pretty good sensor. We found that some of our other sensors, these are new technology, electrochemical printed gas sensors. Some of them are good, and some of them we've decided, okay, good experiment, we're not going to buy any more of those and deploy them. We also do PM 2.5, as you probably saw. I mentioned the cameras, so just so you can see the kind of things that we can do with the cameras, and a couple of examples. Here is the typical view looking down an intersection. You can see that we're capturing, in most cases, an intersection. With the park district, I said, well, if we want to do the park, then we have to make a little bit of an engineering change to point the camera further out. In the meantime, we've got 6 locations going in this fall that will be at park entrances, so we can at least look at traffic coming in and out of the park. And I mentioned all we're doing right now at this point in the project is we've got these object counters that do something like this at the bottom that say this many vehicles, this many pedestrians. We just got a major award from NSF to do the next generation of this technology that will have much more powerful processors so we can start to do more interesting analysis. We also looked upward facing. Argonne, I don't know if it's every summer, but many summers we have a couple of Air Force fellows that come. Usually they're like majors or colonel level people, and they do research with people at the lab. And a couple summers ago, they were interested in whether we could use the existing technology to identify drones. Turned out that was also interesting to the people that manage Soldier Field. And so we got this joint project going. We put 4 nodes around, we call those things nodes, around Soldier Field, and we found that yes, we could actually tell what's a drone and what's a plane and what's a bird, not because of the shape of the object, but because of the movement characteristics. And so that's using very, very small amount of computing power to do that. With the Illinois Department of Transportation and with a lot of really good advice from CMAP, we put a proposal into IDOT last year, and we're just getting started on this project where there are, because we are the hub of rail transportation for the country. That means lots of at-grade crossings. And so if you want to invest, as the state and private and federal folks do, if you want to invest $1 billion to reduce the number of at-grade crossings, which ones are you going to choose that will have the most positive impact on the city? And what we're doing on the south side is putting a couple of our devices to capture information about a crossing event. So easy to know when the gate goes down, when it comes back up again. But how many vehicles were caught in that event? And how many of those were emergency vehicles or public transit? And how long does it take for traffic to go back to steady state after that gate gets up? That's the kind of thing that you can only do with observation or AI at the edges. We're doing. Another project that's similar is a project that's funded by the Department of Energy Vehicle Technology Office. We're working with CDOT and we're working with others to put some nodes out in and around the ground transport around O'Hare Airport to develop a computational model derived from that data so that the city can experiment with different policies or investments to say, if we do this or that, can we reduce the number of private vehicles clogging the airport roads? With Northwestern University and MWR, the Metropolitan Water Reclamation District, Nature Conservancy, we are doing a flood project in Chatham, which is on the south side. This is another sort of shocking map. This is just 1 year of basement flooding reports for the city of Chicago. I'm told that if you wanted to know what's the greatest investment in recovery from natural disasters in the United States, and you eliminate the hurricanes, Chicago flooding pops to the top. So we want to understand, can we use this technology to spot standing water that could be as simple as the storm drain is plugged. Somebody in the city finds out, they unplug the storm drain, and a lot of those red dots go away for that year. Now, just sort of closing, and I was going to leave time for questions, but I couldn't stop talking. So We've been really excited to work with Lane Technical High School in the Chicago Public School District. Lane Tech is about 4,500 students, and it pretty much exactly mirrors in its student body the racial and economic diversity of the city of Chicago by virtue of its admissions system. So it's all the top students, but representative of all the parts of Chicago and all the economic and racial. And so we work with Jeff Solon and Dan Law, who are computer science professors there. And we said, let's see if we could teach kids over the course of 6 or 8 weeks, it turned out to be 8 weeks, to think about a policy or science question, translate it into a wireless sensor device, build the device, deploy the device, collect the data and analyze the data, and then go back and see if you got a satisfactory insight into your question. And we've now done this with 600 students over the course of 4 years. And we've been the last year and a half or so trying to figure out how do we extend this out to the other 100 high schools in Chicago or throughout Chicagoland and beyond. Chicago is, of course, the place that we do all of our work, and it's got the biggest deployment, but we have a partnership program that's been growing. We've actually been throttling the program so that it wouldn't grow fast because we're kind of holding people off until the next generation of our technology, which will be the 5th generation, which we think will be hands down significantly better than anything we've done before just by replacing technology with newer technology. You can see all over the globe, the most recent ones are UIUC down in Urbana and the National Laboratory of Australia, CSIRO, in the lower right there. So I'll just close here. I mentioned that we got a follow-on project from the National Science Foundation to do that 5th generation of our technology. This is actually led by my partner in crime, Pete Beckman from Northwestern University, but also, like myself, at a joint appointment at Argonne. But we have partners from around the country, the biggest of which is a $500 million National Science Foundation instrument that just went live after 20 years of preparation and planning and investment called NEON, National Ecological Observatory Network. And they have these multi-million-dollar towers around the country at all those blue dots, and the large blue ones are the places, the large icons are the places that we will probably go in the next year or two to test out this 5th generation of the technology and then go back and see if we can get a follow-on grant from the NSF, having done the hardware and software and proving ground to push out to all the dots that you see on the map there and maybe beyond. So I'll stop there, and we actually have negative 2 minutes for questions. Yeah. So I'm not sure if there's a moderator coming up.